Many of the techniques you're going to learn in this course for analyzing data depend on the type of data that you're presented with, and so we need to be able to identify those types of data. So in this video, I'm going to look at two of them: discrete and continuous. Now, the textbook definition of discrete data, or a discrete variable, is very straightforward. It says a discrete variable consists of separate, indivisible categories, and no values can exist between two neighboring categories. Another way of saying this would be to say that discrete data, or a discrete variable, can take on only certain values within an interval. So an example of this, an example of a discrete variable or discrete data, would be to ask somebody, how many siblings do you have? So how many brothers and sisters do you have? Well, it's either going to be 0 or 1 or 2 or 3 and so on. You can't have any values other than, or in between the values that I've got here. So for example, you can have 1.875 brothers and sisters. You can't have 2.2 siblings. You either have to have 0 or 1 or 2 or 3 and so on. So there's only certain values that are allowed within an interval, even if the interval goes all the way up to some unknown or infinite extreme. There's only certain values that can be the possible values for that variable. Discrete variables don't have to be numerical, don't have to have numerical values. You could ask somebody, you could perform a survey asking somebody what their favorite pet is with a list of options, and so they could choose cat or dog or turtle and so on. So it's either going to be a cat or a dog or turtle is your favorite pet. It can't be, you can't have a response that takes on a value in between these given values. So discrete data can come in the form of quantitative data, where I've got quantities. Typically counts are an easy way to identify discrete data. Discrete variables are always something we can think of as being counts, as opposed to continuous, which you'll see will be, instead of counts, measures. So discrete variables can be counts, or they could be qualitative categories like cats, dogs, turtles, or it could be something like what is the area code that your phone number falls within. So is your area code 416 or 647 or 905 and so on? These are discrete categories. Within the city that you live in, typically there won't be any options between these. It's not as though you could have any value between 416 and 647 or between 647 and 905. These are going to be distinct and separate categories that are assigned by the phone company, and so you have to fall within one of these categories, but no, you don't have the option of falling anywhere in between. So let's have a look now at continuous and how it compares, continuous variable and how it compares. For a continuous variable, there's an infinite number of possible values that fall between any two observed values. A continuous variable is divisible into an infinite number of fractional parts. So what do they mean by that? Well, an easier way of saying this would be that a continuous variable can take on, instead of certain values, it can take on any value within an interval. Typically, continuous variables are measured variables as opposed to counts for discrete variables. Now, taking on any value within an interval, this would be something like measuring the height of a plant that's growing. Let's say a plant has a container that it can grow within. The container is, I don't know, 50 inches in height. And so the plant, as it grows, can grow from a height of 0 until it hits the top of the container all the way to 50 inches. At any given time during its growth, it could be a height anywhere between 0 and 50 inches. It doesn't have to be 0 or 1 or 2 or 3 and so on. It could be 0.000175 inches tall. It could be just a little bit taller than that. It doesn't have to be any specific or certain value within this interval. A continuous variable can take on any value within an interval. Even if there are limits to the interval, we can't have a plant that is smaller than 0. We can't have a plant within this container that I'm hypothesizing that is larger than 50 inches. Now there is something else that I can say about discrete, just so that it's very clear. In fact, let's do sort of a side-by-side comparison here. I've got discrete and continuous. Now so far what I've said is that discrete could be described as being counted quantities, whereas continuous would be measured quantities. In a lot of cases this is going to help you decide which type of numerical data you have. But this won't always cover things. There are going to be some situations where you would not necessarily count or measure your values, and so you could be confused as to which chapter you should be dealing with. So let's look at another way of talking about discrete. Discrete data has what I'll call either jumps or gaps between the possible values. Oops. But by comparison, continuous data has a smooth transition, or a smooth, I'll call it a smooth spectrum, from one possible value to the next. One of the ways that they'll describe this in your textbook is to say that discrete data, you have a finite or a limited number of values, whereas continuous data has an infinite number of values. Oops, I spelled that wrong. So how does this work? Well, let's start off by connecting these two ideas here with these two ideas here. Let's say, for example, when it comes to counted quantities. Now, if I was to say, how many brothers do you have? Well, basically, you're either going to have 0, or 1, or 2, or 3, and so on. Whereas with continuous, I would be asking you a question where we're talking about measuring something. So perhaps I might ask you, how far do you travel to get to the school every day? Or whenever you do come to the school, how far do you have to travel to get to the school? Now, you might live on campus, so that would be that you travel 0 kilometers to get to the school. But you don't have to have your next value, your next possible choice, be 1 for 1 kilometers. Or if I'm measuring in miles, it doesn't have to be 0 and then 1 mile, and so on. You could have any value in between these possible. Let's say you live only a block away, so it's only part of a kilometer or part of a mile. You could have a decimal. So what decimals can you have? You can have any decimal. It just depends on how accurate you want to be when you're making your measurements. You could have a value of 0.00000001 or 0.000 and so on with a 2, or I could be even more accurate. Basically, between 0 and 1, I can technically have, before I even consider going into the numbers that come after that, between 0 and 1, I can have an infinite number of fractions or partial values. That's allowed with measured data or with continuous data. But you would never get that with discrete data. I can't have between 0 and 1 brothers or between 1 and 2 brothers. I either have 0 or 1 or 2 or 3. So discrete data has jumps or gaps between the possible values. So there's going to be a limited number of those values. Continuous data has a smooth spectrum, so you don't jump from one answer to the next to the next. You could be anywhere between any two possible answers. So these are two other descriptions of discrete and continuous that can help you to decide what kind of data you actually have. Now, one thing that I want to be careful about, though, is I don't want to give you the impression that you can't have decimals with discrete data. Let me give you an example where discrete can have decimals, but it'll still make sense that it should be discrete data. Let's say, for example, that there's a store that sells only 2 items. They sell pop, and pop costs $2, and they sell gum, and gum costs $1.50. Now, if you do a survey where you're keeping track of X, which is the amount of money spent by an individual in the store, and you stand outside of the store, you do a survey, and you ask people when they come out of the store, how much money did you spend? Well, it's possible that a person might say that they didn't buy anything, so they spent 0. Or perhaps they bought just 1 package of gum, so they spent $1.50. The next cheapest thing that could happen, the next lowest price, would be that somebody only bought a pop. Or maybe somebody bought 2 packs of gum. That would be $3. Or maybe somebody bought a pop and a pack of gum. That's $3.50. And so on. So I can keep going. Basically, I can keep going forever. And I can have tons and tons of new values. But what I'll never see is any values between 0 and 1.5. This is not possible. And so if I'm not able to be between 0 and 1.5, that means that I have, like I was saying, I have a jump, or I have a gap between my possible answers. As soon as you see that you've got this sort of a setup, that means that I have discrete data. But in this case, you can clearly see that there's a decimal, here's a decimal here. It could have been that gum cost, instead of $1.50, maybe it cost $1.53. And so I could have had even another decimal. It could have gone from 0 is my first possible amount of money to the next possible amount of money would be 1.53, and so on. So decimals alone do not tell you whether or not you have discrete or continuous data. Instead, it has to be that you understand that there either are possible jumps, there's jumps and gaps between the data, or there's no jumps and gaps between the data.